Welcome, software engineers, to day 18 of CSC 222 software engineering. It's good to see you, logically. It's good that you're here. I appreciate that. Okay, that's funny. Glad you enjoyed it. Say, last time we met, it was 50 degrees colder here than there. And today, right now, it's only like 15 degrees. We're having a pretty warm end of October. As a matter of fact, it's 61 degrees right now. And you're like at 75, 76 degrees or something like that. So I'll take it. We're going to go into a deep freeze sometime. Let's see, was it a week ago? Yeah, a week ago it was snowing. Yeah, well, thankfully, Concordia and Mequon had their fall break last week, Thursday and Friday. You had something similar, I think, the week before that. So it was nice that the days were not terrible, even in spite of the fact that some of us were stuck inside either grading, preparing, or maybe even doing homework. Assignment 16 is due today. I want to say something about that in just a minute. And then CNCS 8, dealing with the 7th commandment, is due Wednesday. Assignment 16, a number of teams have already done that and submitted it. I didn't check just before here, but I checked first thing this morning. If you were able to get this to work and you submitted it, congratulations. As a matter of fact, because I knew this was somewhat of a difficult assignment, I have a deal for you. For those of you that have submitted it now and it's actually working, that will be worth some extra credit. For any team that did not get this submitted, I want you to work on this. I want you to give it a good shot. And maybe if you have to chat with some other team that actually did it for a hint, that's okay, to be sure. So that assignment 16 ... means this. If you haven't yet submitted it, I don't like accepting late assignments just because it throws everything off. But it will not be considered late if your team submits assignment 16 by Wednesday, by the next time we meet. Remember, only one person on the team needs to submit the assignment, and I'm looking for the entire zip file here of that. If you have some questions, feel free to ask, but I really don't want to do logistical things. I showed you that it's possible to do, and you know what needs to be done. And of course, the hard part is, how do I actually pull that off? Good. Week or so ago, I posted this as a notice on Blackboard, announcement on Blackboard. Did anybody try this? Did anybody actually look at that document, go to this link, enter in your e-number and password and see if you can connect? Feel free to post something in chat or unmute if you did. Here's my face. I would like some good student at some time in the near future, like maybe before Wednesday, to actually try this out. Hopefully the announcement's still there. I didn't have an end date for it. It may not be showing up, but if you just drill down from the home page to announcements, you should see this document. The document was prepared by Irvine's IT support department, and they assured me it works. I can't do it because I'm not a student. So I want to see if you can actually do that. What I'm very interested in is see if you can download a license for Windows, either Windows 10 or Windows 11. That way, if you do have a Mac, and you want to run a virtual machine on top of it and Windows, now you can legally license that copy of Windows, and we all feel good about that. That is, I think, would be a worthwhile thing. Oh, wow. Okay. So I hear this from two people. He couldn't get past the authentication. All right. Thank you. Thank you for trying that. I am going to send a note back to Irvine's IT support department, and we'll see. Maybe by finals week, we can get this all set up. Thanks, guys, for trying that for me. I appreciate it. I probably won't let these two go. A week from today is exam number 2. It's entirely possible for me to ask anything that we've talked about in this unit. And although we started this in Unit 1, we keep talking about it here in Unit 2. Software engineering can be defined as the management of the entire software development process. This management isn't just what the pointy hair boss and Alice are up to here. But by management, we mean taking care of everything that relates to the entire process. Management of the process, the software development lifecycle, requirements, specifications, design, and now instantiation, and everything that comes up with those ideas. Management, as we've seen, really needs to know where are we and how are we doing. And it's the software development lifecycle that can help answer those questions. We've described software engineering as, wait for it, professional problem solving. All computer science is problem solving. Coding and programming is problem solving. How is software engineering different? Because we approach it in a different way as professionals. To the outside world, what professionals do seems strange and seems like more work, quite frankly. But when you're doing it, following professional programming practice in the instantiation phase and everything else we've talked about in software engineering, actually makes the process better. There is no silver bullet, no magic solution to make software engineering a snap and a breeze. So instead, we're looking for ways to make it as palatable as possible. What can I do to ensure that we're doing the best possible job? And that's what we've called the aspects of professionalism. Thank you for playing along with me. I've been able to share some with you. Last time we took a little hiatus and looked at these 2 tables of the law, the commandments. So now we're back to, although it's CNCS 8, it's really taking a look at my 7th aspect of professionalism, and that is being honest. Whew. All these are kind of hard, aren't they? Okay, I am really speaking for myself. Yeah, sometimes being totally honest, either with others or with yourself, is a challenge. This one seems to be directly related to the 7th commandment. But notice again, focus on the positive aspect. You shall not steal. Okay, fine. We should fear and love God so we do not take our neighbor's money or possessions or get them in any dishonest way. Here it comes. But help him to improve and protect his possessions and income. Really, that can be a primary vocation of us as software engineers, helping our neighbor, in our case, clients and users of our products, improve and protect their business, their jobs, exactly, improve and protect his possessions and income. And maybe that even relates to non-physical things. Big deal today, of course, is information. Much of our neighbors' possessions are informational, right? Like authentication, username and password. And almost everything we deal with, software engineers, is an informational, not a physical quantity. Yes, it's wrong, of course, to steal a computer, but what about stealing informational things? The whole area of intellectual property. You're probably familiar with this when it comes to digital music files or streaming video. Software engineers would be concerned about people sort of taking their hard-earned apps without paying for it. You'll get a completely different perspective of this when you're the one working in industry, and it's your salary that's being paid for from the profits of the company. If the company is licensing software to other people, well, if somebody copies and distributes that, then the company isn't reaping any reward, and you're not getting one either. And one time I worked for a company that did a cool thing called profit sharing. Hewlett-Packard Company, once a quarter. If the company did well, then everybody got a bonus. The company didn't do so well, well, then it didn't happen. Now, was it because of people stealing the software I was helping to create? I don't know. Okay. Thank you for taking a look at CNCS 8. That is due on Wednesday. Can you relate what's going on there, both to the commandment and to the work of a computer scientist / information technologist? I've shared this with you last couple of times we've met. It's on Blackboard and it's on the syllabus, so I don't think it's a surprise. But a week from today, Monday, the 31st of October, is exam number 2. I may want to chat with you just a little bit before we do the exam. And honestly, I can't remember if we did that before exam 1 or we just jumped into it. But regardless, I'm going to ask you to come and join in online via Zoom. But just as with the first exam, exam number 2 will be online at Blackboard. You would not necessarily have to be connected to Zoom during it, but if you are, it's a way to ask questions if any come up. Same format that you saw in exam 1, true, false, multiple choice, and a few short answer questions. There are different questions, I think. This is a unit exam, so it's focusing on unit 2, things that began on day 11, and primarily focusing on these 2 phases, design and instantiation. Taken together, it's what I call the implementation of software engineering. Idea for the first unit, implementation for the second unit. If you look at Blackboard somewhere, I think before you get all of the assignment details there, you'll see a listing of potential topics, quasi-questions, sort of a way to help focus as you're reviewing. I don't want to call it just a way to focus your attention on what's important in this unit. I mentioned this book one time, and if we have time at the end of the 3rd unit of this course, we might delve into it a little bit. So Fred Brooks, you remember the name, right? Fred Brooks, who I and many other people look at as the grandfather of software engineering, wrote a number of very influential essays over the years. You've read The Mythical Man Month. You've read No Silver Bullet. Next, you'll read an influential article called Computer Scientist as Toolsmith. And this is his most recent one at the end of the 2010s or something like that. Fred Brooks is an old guy like me. I don't know how he has the energy to keep doing this stuff. I'll just show you one little bit of this. Of course, in Google Books, you can't see all, well, I don't know. Typically, you can't see all of the document. You can see portions of it, and they have some things that are, grayed out, etc. here. Unfortunately, you can't see the chapter 1 title page, but that's okay. Interesting quotes. Don't you like it when people begin things with interesting quotes? I don't know. Maybe it's just me. New ideas would come about by a connection and transferring of the observations of one art to the uses of another. When the experience of several mysteries shall fall under consideration of one man's mind. Don't you like Old English? Kind of like reading Shakespeare. Sometime in the middle of this unit, I mentioned you're at a great place to learn computer science and software engineering, Concordia University, Irvine. Why? Because Irvine is a liberal arts school. Seeing these different ideas and these connections really helps us think. Are there invariant properties of the design process itself, properties that hold across a wide range of media and design? What Brooks is trying to do is to help us as software engineers see that what other people do in their vocation, when they call it design, whether that's industrial design, whether that's computer aided design, whatever, photography, whatever it might be, are there things in other arenas of design that can be helpful to us in software engineering? The OED defines the verb design as to form a plan or schema, to arrange or conceive in the mind for later execution. Well, for those of you with nothing else to do, I would encourage you to go to Google Books and look for the design of design, or you can run right out and buy it. Either one of those are fine. Anything you need, I would share with you, but it's interesting read. We don't have to know anything about it in Unit 2. We began this unit with design, and now we're in the midst of instantiation. You know I like that word, right? Instantiation. What's it mean? Change design into code. Simple. Simple to say, harder to do. Impossible to do without a good design. Definition: change design into code. Now, you can use lots of different nouns instead of the noun code. We could legitimately talk about a program or an app, or in the workaday world, we can talk about a product. It's all the same. The code, the program, the app, the product, that's our goal. We want to get this out of our mind. And you're saying, well, design isn't in the mind. We've written it down. True. But it's not in a form that a computer can execute. So we've got to get it out of design into some form the computer can actually follow. All right. So last time we talked, we did caps A through D. That's going to bring us to cap E under instantiation, code verification. Let me review with you. There are two aspects of testing. Validation. Validation is something that happens at the beginning of any phase. We ask ourselves, are we doing the right thing? We compare, we look at the previous phase, get our mindset right, and then begin. The other aspect of testing is verification. And the reason I have testing in parentheses there is because most of us, all we've done is this, the verification that happens afterwards. and especially in the context of code. Okay. Code verification, testing. How do you do it? Let's start off by getting a big picture, first of all, and then we'll fill in some details. You'll hear a couple terms associated with testing. You'll hear the term alpha testing. Alpha is the first letter in the Greek alphabet, so first level of testing. By definition, and I wish everybody played the game correctly, but sometimes you'll hear these things mixed up. Alpha testing is in-house testing. The company that's producing this product will actually do the testing. You're saying, but of course, alpha testing. So you are company team Z. You produce something. Now, the first level of testing is you, team Z, testing out the product. Alpha testing, in-house testing. The same company that created the code is now going to verify the code. There's another general class of testing, and that's called beta testing. Beta is the second letter of the Greek alphabet. So this is the second level of testing. Okay, now think about it with me carefully. Let's see if you'll play along. If alpha testing is in-house, then beta testing must be out-house. Of course. What we mean by that is out of the company. Beta testers are people outside of the company that produced it, actually doing the testing. Now, that could be other companies contracting to do this. The problem is, you're likely familiar with companies that talk about users, excuse me, users doing beta testing. And when Microsoft has 100,000 people testing Windows 11, that's not beta testing. When Apple has 200,000 people testing Mac OS, whatever, that's not beta testing, okay? It's a legitimized testing with people who know what they're doing outside of the company. Excuse me. So, how do we do that? Whether you're doing alpha testing or beta testing, how do you test? Well, here's a key idea. You have to test against something. You have to test against something. What would that be? The answer is the specifications. The specifications tell us exactly what this product should do. If we want to ensure the product does what we said it will do, then we'll test against the specifications. Specifications say produce a running total. Test to ensure that this app produces a running total. The specifications say this app will print a label. Test against that. Does it actually print a label? And so it goes. The specifications not only were the input to design, so we could figure out how to do any of those things, but they then also serve as our benchmark for verification, for code testing. Test against the specifications. I'm going to say this 3 or 4 times today, and then I'm going to try to prove it to you next time. This process of code verification, testing, cannot, note the emphasis, cannot improve the quality of a product. Testing cannot improve the quality of a product. Historically, and by that we mean most software development processes, historically, Verification of any kind only happened at the end of the life cycle. Well, guess what? If you're behind schedule and you haven't done testing, some folks are willing to bypass the testing in order to stay on schedule. Let's think if that's a good idea or not. Your sales rep told us that the product heals itself. Is that true? It's totally true that he said that. Let me ask this another. No! One way per question. You thought you'd be able to slip out of that being honest, didn't you? Yeah. All right, why are we doing this? Does it seem obvious to you why we should test? You probably weren't thinking about this, were you? Do you know why we test? We test to find errors. The purpose of testing is to find errors, bugs in code. We'll say more in a bit. You were thinking, well, the real reason is to know the goodness of our product, right? We'll test, we won't find any errors, and then our product will be really good. If you test and don't find errors, you're not really testing. Sure, part of this is so we can have a good, warm, fuzzy feeling about our product. But the actual purpose of testing, code verification, is to find errors. Have you heard this before? You cannot test in quality. You can't test in quality. I know that's a grammatically incorrect sentence, but what I mean to say by that is, if I do enough testing, will that improve my product? And the answer is no. You can't test it in after the fact. So some of you are thinking, what's that mean? It has to be designed in from the beginning. The purpose of a test, the purpose of testing, find errors. What's the goal of testing? See, I didn't say find errors again. Look, something different. Uncover problems. You may never have heard this before. Question: what percentage of commercial software application packages contain errors? Before you answer, let me tell you, answer 100%. Every single commercial application, by commercial, I mean anything that's worthwhile. I don't mean the noise generation app on the App Store. I mean anything that you or a business would legitimately pay a license fee for. All software contains errors, multiple errors. Go look up what the latest release of the Mac OS or Windows 11. You have to dig, but both Apple and Microsoft will tell you those products are released with thousands of known issues, bugs, errors. The goal of testing is to uncover problems. I've got to say it again. A good test finds errors. A good test finds errors. Here's the scenario. You test your code and you don't find any errors. One of two possible conclusions. Number one, my code is perfect. Number two, bad test. A good test finds error. There are errors in any legitimate piece of software, anything bigger than toys. There are errors there. And a good test finds and uncovers those errors. Who wants to share knowledge with me via our new intranet collaboration software? You don't have any knowledge to share. Ouch, it hurts because it's true. Would you have to? Okay, I think you see. All righty. So we're testing, we're doing code verification, and we've got good tests. So guess what? We find some errors during testing. Errors found during testing. What should you do? Error. What should you do? Here's what not to do. Don't stop testing. If errors are found, don't immediately stop. Instead, continue with your plan. Continue testing. Sometimes, I found an error. I'm going to stop now. I'm going to go do something about that. No, don't do that. Continue with the test plan. Keep going. We'll see why. For now, just say yes. Errors are found. Don't stop testing. Keep going. Once we've completed testing, now it's time to do some management. This is why we didn't stop immediately up front. Now we need to manage. We need to determine the severity of the errors and prioritize. Determine the severity of the error and prioritize. By prioritize, I mean, what order are we going to fix these things in, if we even fix them at all? And this is shocking. You may not correct all errors. In the little chart that you see there, and most companies have more than just a 4-slice pie, or however they're doing it. You can see high severity, high priority, the red, high severity but low priority, high priority, low severity, low priority, low severity. What's going on here? Well, the severity is how terrible the error is, and we'll see some classifications later. And the priority is, which ones do we want to fix? Are you saying it's possible you might have a fairly severe error that you wouldn't necessarily fix? Or something that's not really a severe error, but is really high priority? Yeah, both of those are possibilities. You may not correct all errors. Different companies use different classification schemes. When I worked at Hewlett-Packard, we had 4, and I, along with most people, find 4 kind of hard. 3 seems to be a natural number. Okay. So, critical, moderate, trivial, or however, there was a severe level in between critical, severe, moderate, and trivial. But anyway, we just have 3 levels of errors, and there'd be ways to classify them. There'd be some guidelines. There'd be other members of the team that could help. We'll talk about QA in a little bit, but just realize that not every error is of the same severity. If the algorithm produces incorrect information, that seems very severe. If the icon that represents the product is the wrong shade of blue, that doesn't seem quite as severe. So here's another one. Okay. Critical, non-critical, low, and urgent. Just people are going to have different terms. This one also has 4. Critical, major, minor, low. Okay. So you see this one here, they have 4 different levels also. Critical, major, minor, low. And then the priority, immediate, high, medium, low. We're not going to worry so much about how do I deal with these categories, but I want you to see that this is part of the management of software engineering. It's not just, okay, here's a list of 29 different errors. No, you need to prioritize them, You need to talk about not only how severe they are, but what about the priority of them? I usually have a hard time speaking because by this time on Monday, Wednesday, I've already done 4.5 hours of classes. Today, my one graduate class, we were doing something, so I didn't do it. So why am I still having trouble? Just must be I'm old. And I look, where you are, it's probably still light outside. It's dark outside where I am. Now, I know you want to talk about this, so I'm going to put it here. But this is important to recognize. Debugging is not testing. Debug is not testing. When you're debugging, you're doing something different than testing. Before, when I said testing cannot improve the quality of the product, you were thinking in your mind, but I find that error, then I'm going to correct it. That's not testing. Thank you. What is the definition of debugging? You say, well, that first part, sure, correct errors in the code. What's this without? The purpose of debugging is to correct errors in the code without introducing new errors. Coders don't think about this often. Software engineers do all the time. Making changes to a code may not be perfect. If you couldn't write the code perfectly to begin with, what makes you think you can change it perfectly? Debugging oftentimes introduces new errors. Darn. So in other words, you must change the code if you're debugging, but notice you might have to change the design. Maybe you see this error and you say, oh yeah, well, the code did what the design said, but the design wasn't based upon the specifications. The spec said, print a label with this on it, and the label doesn't have that on it. And the design didn't say to do that. Don't just change the code, change the design document also. Okay. Must be that time. Would you like to stand up? Sure you would. Okay, let's do it. How long do we take? 20 minutes? No, 1 minute. Synchronize your watches. Okay, stand up. Stand up, walk around. Don't forget to come back. That's important. Are you still there? 30 more seconds. Okay, it's close. Well, that's got to be enough, right? How is testing done in practice? Let's take a look at some of the aspects. So a little more, this E was a little bit more of theory. Logistically, how is testing done? Guess what? You have to have a plan. You could probably deduce what this plan is called. It's called a test plan. Exactly. Like everything else in software engineering, you need to manage it. And you manage it with a plan, the test plan. Okay. Now, we hate to ruin a good cartoon by saying so. This is funny. See, beta testing at Volkswagen headquarters. Oh, does Volkswagen still make the bug? You remember a million years ago, they made a bug, then the bug came back and stopped, then it came back, then it stopped, whatever. Bug, see. Now, too bad. You know what's wrong with this? If you're at Volkswagen headquarters, you're not beta testing. You might be alpha testing, right? But see, if this is Volkswagen making their software that ran their diesel engines, somebody else should have been testing that. You have to plan testing. As with any other activity in software engineering, if it's not planned, it won't happen correctly. Sometimes even planned, it won't happen correctly. But without a plan, the odds are minuscule of things happening correctly. Besides, this is part of being a professional. Professionals plan their work and work their plan. Create a test plan, note, which lists two things: the input that you're going to give to the program and the expected outputs. A test plan lists both the inputs and the expected outputs. So I'm going to give this 0.1, 0.2, 0.3, 0.4, 0.5, and it's going to return to me 1.5 as a running total. You can't just say these are the inputs I'm going to give. Let me demonstrate. Otherwise, if all you did is list the inputs, you can be fooled by correct looking output. And give you an example. By the way, for those of you who've wandered too far away, you need to come closer now, because in just a minute, I'm going to have you chat. And first of all, we'll chat to everybody, but then you'll just chat to me, because I'm going to ask you some questions and I need you to respond. I need to see what you're thinking. If you don't list the expected outputs, you can be fooled by correct looking output. For example, you are developing a financial calculator. And one of the features in the specifications is this financial calculator will determine monthly payments. If you borrow a certain amount of money for a certain interest rate over a certain period, this financial calculator will tell you your monthly payments. All right, good. So, all right, well, let's write the test plan. I'm going to borrow $50,000, 9%, 10 years. If that's all you do, and whatever the app spits out might look correct. For example, which one of these is correct? I'll go back in a minute. Well, you can do this one to everyone. In a minute, I want you just to DM me. So answer via chat, okay? You type in A, B, or C. They all look plausible, right? Which one of those is the actual correct value? I need you to do this now. I want you to go to chat. I want you to message everyone, including me. Pick one of these, A, B, or C. Are you ready? Go. Did you not come back from our break? Thank you. Go to chat. Maybe if you don't chat, you're not really here. This will be roll today. Oh, the point of this was not to browse somewhere online and answer the question. I'm sorry. I didn't mean that you had to actually do the computation either in your head or somewhere. Just which one do you think it is? I mean, they all look correct, right? No, none. What a trick question. That'd be terrible. All right. If you haven't done this yet, do it quick. Do it quick. But see, this is exactly the point. Unless I knew what the answer was, if either A, B, or C came out, I'd say, well, that's fine. Now, if minus 39 came out or 10 billion came out, there's something wrong. But all of these, of course, are in the ballpark. And believe it or not, yeah, the answer is actually B. B is the correct. Do I have that here? Yeah. B is the correct answer. But or imagine it was 600 and 633 and 650. Even if you could somehow do this in your head, I mean, estimate it, we wouldn't know. Moral of the story, testing has to be planned. You need to list not only the inputs, but also the expected outputs. And you're saying, how would I know that? Might have to do it manually. Yep, sorry. This is a task, isn't it? Testing is a very different mental activity than being the creator. In order to test well, you have to develop a tester mentality. You have to say, I'm going to break this system. When you're creating it, it's your baby. You don't want to hurt it. You want to nurture it. You want to love it. You want to say, yeah, come on, you can work, you can do it. When you're testing, you got to say, die, break. Switch gears from creator to tester. And this is hard to do. And this is why many organizations don't have the developers test their own code. Either a separate department like QA, which we'll talk about later, or even outside the company, beta testers. Because switching gears from loving your product and wanting it to grow to testing it, wanting it to break, that's hard. Okay. Now, in the actual practice of testing, there are two terms that you'll hear, not alpha and beta, but dealing with the actual implementation of the test itself. The first is called white box testing. It would be more accurate if we called it clear box testing. Some people do, but the historic term is white box testing. The idea is, think of your code, your app, inside a clear box. Or this is testing with knowledge of the code. So when I test, I can actually look at the code, see what the code says, and then pick up some insights into how to test it. So one type of testing is white or clear box testing, testing with knowledge of the code. So, okay, this time I'm going to ask you to chat, but I want you to just send me, don't send it to everybody. That'd be cheating. Do you know how to do that in the chat box? You should see a little pull down, and by default, it says everyone. Click the pull down and send it to Gary Locklear. That's me. How would you test? Sorry, don't do it yet. Not with this one. I'll tell you. Let me do the first one. Thank you. How would you test this? Let's message everyone in the meeting. Do you know what a switch is? A switch in C#, and there are other C-like, many languages have a switch-like statement, is a is a extended, that looked weird to me, if statement selection construct. Okay. So if I were testing this, I would say, these silly words are, think of these as a method somewhere, this is a function call, or these are just some statements or something like that. Okay. So what I would do to test this is I would provide 4 input test cases. First, I would ensure that letter was an X. Then I would ensure letter was a Y. Then I'd ensure letter was a Z. And then finally, I'd have something else. Pick something else. Letter is Q. There's my 4 test cases. And I can exercise either those 4 methods, those 4 statements, those 4 procedures, or whatever it might be. And I would have to state what does blah, blah do? Well, I'd have to list that also. Fair? Okay. Here's the problem. We're using the virtual dentist hardware with the virtual optometrist software. Okay, now it's your turn. Just so I gotta tell you what to do. First of all, look at this code. Console.writeLine in a console application. Oop, don't do that yet. Console application. This will just output something. Guess what this does? It's just going to read something from the user. So rather than using a text box on a form, I'm just doing it in a console app. Okay. What's the average? The user types in. Okay. Average. I've got average. Okay. Now, this is what I want you to do. This is important for you. Here are 3 inputs. I've given you the inputs. So now you write the test plan, but you write it to me as a message. You chat and just send it to me. You know how to do that. When it's 2, click that pull down and just find my name there and send it to me. Here's the inputs I want. Now, in the test plan, you have to tell me what's the expected output. What do you expect to see for 25 as the average? What do you expect for 65 as the average? What do you expect for 95 as the average? Okay. See? No, it can't be to everyone. Sorry, I just reused that one. This here needs send it to me. Answer via chat to me only. Okay, so let me go back. Tell me, remember, I'm taking roll with this. Wow. Some of you are pretty good. You're all really good. Some of you noticed something. White box or clear box testing is testing with knowledge of the code. You look at the code and say, okay, here's what's going to happen. Course will verify by actually running the app and inputting these values. Thank you. Another few seconds. What's the output for 25, 65, 95? Interesting. Interesting. All right. Go ahead. You're still in the middle of typing. Go ahead and do that. A number of you have noticed something. The indentation here would lead you to believe something, but that's not exactly what happens. Okay. This is what happens when you execute that code. For an input of 25, nothing is output. you would expect it would say failing, but it doesn't. An input of 65 says passing but marginal. I mean, yeah, that's what you expect. But then an input of 95 says failing. What's going on here? Why is that? Yeah. Problem. This is a classic problem called the dangling else. Oop, sorry, the formatting here got a little screwed up. Let's go back here. This is called a dangling else. My indentation leads you to believe that the else goes with this if, but it does not. The way that the compiler parses this is this else goes with this here. Now, when you read it that way, you can see what's going on, right? If, go ahead, otherwise, ooh, yeah, exactly. So how, now we test, we say, oh, this is not what I wanted at all, right? But in order to correct that, you need to debug. Debugging is not testing. Now I got to go back and I got to make a change. Testing reveals an error. We did not get the expected. The specs say that's not what you should get. Testing reveals an error. So let's correct the code. This is debugging, not testing. In this case, likely the design was correct, but the implementation, the instantiation in C# was not correct. So now we're in a debugging phase. Change. I don't want to do it. Okay. Debug the code. Now, let's not spend time with this. Let me just tell you. Okay. To debug this code, note the braces here. Note the braces here. Otherwise, the else is associated with that. We want the else associated there. Throwing the braces around there will get us what we want it to do. Now, just say, oh, it doesn't say. Now it will actually print out the value for passing but marginal and failing correctly. And 70 or above, it won't say anything. Good? You don't believe me, do you? Try it out. Chuck Norris cannot fill out an online form. Chuck will never submit. That's a good, I like that one. That's funny. See? All right, let's do this one instead. So, hey, Zeke, why is there music coming from your printer? Zeke, that's just the paper jamming again. Trying hard here, folks. All right, see where that gets you. Don't laugh. We'll just see what happens there. Clear box or white box testing is testing with knowledge of the code. I bet you can deduce what black box testing is. The term black box is used in a lot of context, meaning you don't know what's inside. It's opaque. You can't see through it. Like the black box in your car or an airplane, the data recorder thing. Yeah, exactly. So if I can't see the code, well, how do I test? Well, the only thing you have available to you then is the specifications. Black box testing relies solely on the specifications. So I wouldn't look at design. I wouldn't look at C# or instantiation. I'd go back to the specifications, see what they say, and then develop a test case. In other words, I don't know. All I know is it'll convert the input to the output. Oops, sorry. It'll convert the input to the, I don't know what the process is. I can't see the code. But does it matter? It doesn't matter for testing. Now you're saying, well, I need to see the code. I'm going to debug. Yes. And debug is a different activity than testing. So just as before, you're going to list the input data and the expected output, And that's all based upon the specifications. We can't see the process. That's okay. Theory tells us that white box and black box uncover different kinds of errors. A company will legitimately do both kinds of testing, white or clear box and black box testing, because they uncover different kinds of errors. There is some overlap, and what do I want to say? I was going to say testing shows, but now I'm talking about testing about testing. Studies show that both white box and black box testing uncover some of the same errors in a piece of code, but actually there is at least a third difference between what black box and white box uncover. Don't remember any of that. I'm just making it up. But just remember they uncover different kinds of errors. Both are important. If you're going to legitimately test, do code verification, you'd want to do both black box and white box, and you want to have both alpha and beta testers involved in the process. The other day in a class, I mentioned ID10T, not you guys, but somebody else. And at least half of them had no clue what I was talking about. I guess I'm old. If you've never heard of ID10T, an ID10T issue, it's a common IT phrase, sort of like flip the bozo bit. So you can see Ted got this shirt, ID10T. Well, if you write it out like that, you notice it may also spell a word. Okay, so now you know. You don't want to be the ID10T. See all the interesting things you learn in this class? We're getting kind of deep. We're skirting the area of computer science theory. It's okay with me because that's my field and I love teaching it, but don't let me go too deep. Combinatorics, the word's not scary. You know what the word means. But theory shows it is impossible to test either all paths or all inputs. It's impossible to test all paths through a code or to give it all possible inputs. We won't prove it. And if you don't believe it, just believe it. It's impossible to completely test any product. Therefore, we must test intelligently. How do we do that? Intelligent testing says, well, we need to make partitions or groups of test cases. So I don't have to do everything, but I could just pick a representative sample, and that will suffice for a group of tests. This was kind of funny, but later. You know what? Let's cut to the chase because I want to give you some time to meet in a group so you know when you're meeting again. Intelligent testing employs these two concepts: equivalence testing and boundary value analysis. Equivalence testing, boundary value analysis. Let me give you an example. Let's say that the app that we're charged with testing, the specifications for this, say the database will handle from 1 to 127 records. All right. So how are you going to test it? Well, probably by having it with some number of records. Sounds good. What we're going to do is we're going to break this into so-called equivalence classes. Any number within the class should be fairly equivalent to any other number. That's the idea of an equivalence class. Any value, any number in the class should be fairly equivalent to any other one. So now you're saying, how in the world do you do that? Well, you can fool it into thinking there is zero. So here are 3 equivalence classes: less than 1 record, from 1 to 127 records, and greater than 127 records. 3 equivalence classes. Equivalence class testing would say there's no reason to do all 127 different combinations here. I can pick a representative sample. But now we add to this the concept of boundary value. Again, survey says that many errors occur at the boundaries of equivalence classes. So we'd end up with really 7 different test cases. And here they are. 0 records, which is a member of equivalence class A, and it's adjacent to the lower boundary. 1, which is a boundary. 2, which is adjacent to that. 96, which is just some random member of equivalence class B. 126, adjacent to the upper. 127 is the boundary. And 128 is a member of C and also of that upper, yes, it's of that equivalence class C, and then also at that upper boundary. So although we didn't do every single test with these 7, we can feel very confident if all these 7 test cases pass, that we've done a good job. Cool. Next time, we'll talk about regression testing. When you fix one bug, you introduce several newer bugs. Oh. Do you remember what teams you are on? Okay. Well, let's do this first of all. Last time we met, I created 7 different teams. Hopefully, again, you can self-assemble. Before you go there, let's finish this up. I'll stop the recording, then I'll let you jump in there. What I want you to do as a team is, first of all, if your team already completed assignment 16, give everybody a logical high five and you're done. If your team has not completed assignment 16, figure out when you can get together to work on it, or assign things to somebody and have them report back. Be sure you have the contact information for everybody else. All righty. So if you can remember which one you were, and again, I haven't updated the names yet. I will ask you probably on Wednesday to make some kind. That's another thing all teams can do. You could just try to start hashing out, what do you want your team name to be? And then we can refer to you as team whatever, as opposed to team T or team Z. All right. Okay. So I'm going to say goodbye so I can stop the recording, and then I'll go find the listing of team members, throw that up so you can see where you need to go. All right. Folks, thanks so much for playing along today. I appreciate it. Continue to work hard. Have a nice day. Have a happy Tuesday. I will see you on Wednesday. I'm going to stop the recording.